Good afternoon, everyone, and welcome to the second public webinar on the creation of a feasibility study to explore the potential of wind energy generation on the Great Lakes. I am Cheryl Huber with NYSERDA's Great Lakes Wind Team and will be leading us through our series of presentations on this topic. It's nice to see you all again. This is the second in a series of 4 presentations that NYSERDA will be hosting this year. Building on the information provided in March, today we have the opportunity to hear directly from the research teams conducting this study. They will be presenting their study topics in greater detail and describe the methodology that will inform the science to support Great Lakes Wind Feasibility Study. Next slide, please. But before we begin, I would like to mention a few points of webinar logistics. All attendees will be muted for the duration of the webinar. You may submit a question for our question and answer period via the Q&A feature at any time throughout the presentation. The chat is disabled, but you will be able to communicate with the Great Lakes Wind Team and panelists via the Q&A. Today's webinar is being recorded. The slide deck and recording will be posted to NYSERDA's Great Lakes Wind website along with the first presentation from March 19th. If any technical problems should arise during this webinar, please email Sal Graven at the address shown here. Next slide, please. The agenda for today's webinar outlines the topics covered during today's presentation. The study is being authored by 3 contracted teams, the National Renewable Energy Laboratory, or NREL, as you'll hear throughout this presentation, Advizion, and PTerra Consulting with the Brattle Group. Each team will describe aspects of their scopes that will comprise the study. We will hear from NREL and technology development to address lake depths and ice conditions, a cost and cost reduction analysis, and an overview of economic development opportunities related to potential Great Lakes wind. Next, Advizion will provide an overview of regulatory processes needed to permit Great Lakes wind, a risk mitigation benefit analysis that will consider various topics, including environmental conditions and sensitivities, investigations into lakebed conditions, including sediment and geohazard studies, and a visualization study to address potential viewshed impacts. Finally, we will hear from PTerra Consulting on joint work with the Brattle Group on how energy will get to shore in their grid interconnectivity analysis. NYSERDA will then provide additional resources for information on the study and opportunities for public feedback, including an invitation to a virtual public feedback session in June. And the schedule for the remaining webinars is scheduled for this year. Finally, we will conclude with a Q&A session where you'll be able to ask questions to the members of these research teams. Next slide, please. During today's presentation, we aim to revisit the impetus for conducting this feasibility study, then elaborate on the overall study description we provided back in March. We will hear more details on topics that will be found in the study, many of which are important to you. This is an opportunity to engage with the researchers and ask questions about their methodologies for this study. We hope at the end of today, NYSERDA will have provided a comprehensive overview of the purpose, intent, and content in the feasibility study and invite you to a dedicated public feedback session for your input into the study as well, which will be described in further detail later. Next slide, please. As a reminder, the scope of this study is to include Lake Erie and Lake Ontario and the New York communities along these shorelines. This map is a regional snapshot that shows depth contours of each lake, which is an important consideration in the study. Next slide, please. New York State's energy policy has a clean energy standard that is designed to fight climate change, reduce harmful air pollution, and ensure a diverse and reliable low-carbon energy supply. Under the state's nation-leading climate legislation, the Climate Leadership and Community Protection Act of 2019, or the Climate Act, the Clean Energy Standard was expanded to require 70% of New York's electricity come from renewable energy sources such as solar and wind by the year 2030. On October 15th of last year, the Public Service Commission adopted an order to further expand the state's Clean Energy Standard, instructing NYSERDA to conduct a feasibility study of Great Lakes wind energy to consider the environmental, maritime, economic, and social issues, as well as market barriers and costs of developing wind in the Great Lakes, as an important next step in assessing the overall value and viability of this potential resource. The Commission directed NYSERDA to commence this study within 180 days of the effective date of the order to be completed with a total budget of $1 million. The timeline and budget for this study are on target, with an expected completion of the study at the end of this year. Once the study is completed, NYSERDA will submit it along with recommendations to the Public Service Commission to satisfy this order. The Great Lakes Wind Feasibility Study is not a planning document. Rather, it's a non-directional information collecting exercise based in sound science that will inform future state policy toward achieving our renewable energy targets with the potential inclusion of Great Lakes wind as a renewable energy resource. Next slide, please. With that said, your public participation and input into the study is extremely important and valued by NYSERDA. Throughout this process so far, we are hearing what concerns you and what you would like to see included in the study. Here is a summary of some concerns we have heard to date. Many of these will be addressed during the course of today's presentations. We are also providing additional resources on our website that answer a number of these questions and others. Next slide, please. The construct of the study team is shown here. While each contracting team has expertise in the subjects they will cover, many of these topics are interrelated, and it is important that information is shared amongst all of the teams. NREL is the leading agency coordinating all of these pieces and producing the study for NYSERDA. The work began in February of this year and is expected to be concluded by the end of 2021, with a final product in early 2022. In each quarter of 2021, NYSERDA is conducting these periodic updates via webinar to inform the public on the study. Next slide, please. I'm pleased now to introduce Walter Musil of the National Renewable Energy Laboratory, or NREL, to describe his team and their components of the feasibility study. Over to you, Walt.
Okay. Thank you, Cheryl, for that introduction. And this slide obviously is showing our team. There's 8 members that many of them are on the call right now and will be available later if there's questions, if we have time. And I just want to recognize that everybody's participating in this, and we have different subject matter experts for the different categories. And next slide, please. I'll show you what those are. In this Great Lakes Wind Feasibility Study, we're really pleased to be able to coordinate in the first task with the different groups that we're working with, Advisian and Brattle and Patera, and that's really the first task of this. But this is a feasibility study, and we're also very pleased, and our specialty is really in the technology side of this. So we're doing the technology feasibility study in particular, and that really begins with the topic of wind plant technology review, which consists of the evaluation of the site conditions and the evaluation of the technology options that are available to the Great Lakes in this context. And they're related because the technology is constrained by some of the conditions that we have, and I'll get into that a little bit. So we put those together to do physical siting analysis at the end of that first task, and then we pass that over to the economic and analysis team that's going to do cost analysis and economic analysis on the specific conditions that we find, and that will be for both fixed bottom and floating scenarios that we'll develop because we anticipate that there could be an opportunity for both those technologies. The shallow waters of Lake Erie might be one technology, and then the deeper waters to get further out in Lake Ontario would be potentially a floating system. And we use our cost models to do that, and then we will use that information to develop the economic and workforce opportunities using our jobs models. Next slide, please. So just talking specifically about the site conditions, first we're going to look at bathymetry. That's just a technical term for water depth. We're going to be looking at the water depths, and this is fairly straightforward using data that's available from NOAA and peer-reviewed literature, and you've already seen the maps that we've done on that. Then we get to wind resource. This is where the energy is made, and it's very important that we understand the conditions of the wind resource. We just did a new study that's using 21-year time series from the Weather Research and Forecasting Model that's available at NCAR, the National Center for Atmospheric Research, and we've just processed that already, and we'll be showing you those. We have a small teaser map coming up, but that work is getting done, and it looks really good as far as the wind resource is concerned. The next item is ice climate, and whenever someone talks about the lakes and freshwater ice, this is the topic that is mentioned most. In fact, there's a project in Lake Erie called Icebreaker. That's what they named it. The extent of the ice cover is important, and it varies from year to year. The ice thickness, and in particular, ice ridges that form and create extra thick areas that have to be calculated in terms of the understanding the structural loading on the system. And we have a range of sources on that, and that's going to be a focus of the technical feasibility of this study. Next slide, please. And then continuing on with site conditions, we have to understand what's on the lake bottom. These are the soils that are on the very bottom of the lake, and are they compatible with the substructures that we're trying to assess, and whether they can be used in the lake. Some can and some will not be able to be used, because in some places there may be bedrock that will prevent certain types of anchors or substructures. In other places there may be just softer soils that might impact those choices. So we need to investigate that, and we have a literature search going with that, and assessments from the U.S. Geological Survey. In the topic of waves and currents, this is important, but it's not a driver really. The waves in the Great Lakes are not that big, and the currents are not that strong, but they do have to be considered in the designs. And maybe one of the more important ones is the ports and transportation, which is the far right one. And these are the areas where technologies may be constrained and limited, and you will find that this changes the types of technologies that the lakes can deploy in comparison to what's being deployed currently in the Atlantic Ocean. And we anticipate smaller turbines might be necessary, and different types of port infrastructure. Next slide, please. So just diving in a little bit into the technology assessments, we are going to look at fixed bottom substructures and how they might differ from what people have seen in the Atlantic Ocean. One of the things that's notable on this figure on the right is the ice cone. The ice cone is a way of reducing loads due to ice flows, FLOE. That's a term for the sheets of ice that migrate across the lake during thaws, and they can, as they crash into the towers, they can impart loads, and the ice cones really reduce the loads that the wind turbines have to take. And so that's something that adds cost, but it also reduces cost because the loads are less. And so we've seen plenty of examples in Europe on how these are used, and they work. We've also seen examples in the Great Lakes where they use similar things in bridges and bridge technology. LeadCo is, as I mentioned, is a project in Lake Erie that's also developing similar systems for fixed bottom, and that might be the typical for Lake Erie, where the waters are shallower. Next slide, please. In deeper waters, floating substructures will probably be needed, and that might be more characteristic of technology that could be deployed in Lake Ontario. These ice forces are still transmitted through the structure in the same way. We need a slender profile at where the tower or the substructure penetrates the surface to reduce those ice loads, and we have to avoid structures that might jam the ice up. But we have to primarily understand the loading that ice creates. Next slide, please. And so, this is a pretty well advanced understanding in terms of offshore wind. We understand how to calculate the aerodynamic forces. We understand how to calculate the hydrodynamic forces, and the ice models exist, but we are going to do an evaluation of those ice models to make sure that we can calculate the ice loading, and that it doesn't create a completely different scenario for for structural design. And everything we've done so far indicates that it will not. It will be it'll be fairly routine, but it has to be accounted for in terms of the engineering. There are two ICE models that we're looking at right now. One's developed at the University of Michigan, one by DNV. And we're particularly concerned with characterizing that ice in terms of the ridges that form, and make sure those ridges are the if they're the extreme ice load, we need to understand what they are. Next slide, please. There we go. So then we move to our cost modeling, and we have two models. We have a model called ORCA, which is more of a regional geospatial cost analyzer, and it creates these maps that you see on the lower left. These are levelized cost of energy maps that we did for California. And you can see that there's two maps. One represents a present day situation, and one is a future projection of what those costs will become. And anybody who's been following offshore wind knows that the costs are coming down rapidly. And so we project lower costs in the future than we do now. And the question is, how low will they get? And it's based on technology types, it's based on market maturity, and a whole range of other things. On the right side, there's a figure that shows the impact of costs. This is just an example of how it might affect the balance of station costs. That's everything but the turbine itself. How those costs come down as the turbine rating gets larger. So if you select a slightly smaller turbine, you're going to sacrifice a little bit in cost, but there's going to be a trade-off in many ways, and how to get there. So we have two models. One is called Orbit. That does the local kind of process-based analysis on project-specific things like this turbine rating, and then there's the global, more regional cost analyzer. Next slide, please. So in the when we do this analysis, first we generate a scenario development. We look at both fixed and floating. We're going to look at capacities. How big should the project be? What kind of technologies will be used? And then we'll work with NYSERDA to locate representative projects, just so that we can do cost analysis to see how the costs might vary from site to site. And we will customize the model to make it account for the specific conditions that we know are unique to the lakes. And Erie will probably be different than Ontario. So we have different port requirements, different turbine size requirements, cable laying, et cetera. The supply chains that are there or not there have to be accounted for. And then we'll do sensitivity studies that will generate these heat maps that you've seen for California and places like that, where we can calculate how the costs will vary from site to site. And will there be a strict penalty for distance from shore, for instance, and I know there's a desire to move these projects as far away as possible. So we're going to look at those trade-offs. And this map is a very small map, but it is the new resource map that we have for the lakes. Next slide, please. So then we move to our economic development and workforce part of the project, and we start with our jobs and economic development impact model, JEDI, which looks at wind-specific output for project-specific conditions, and we'll be estimating the gross economic impacts, not the net impacts, but because jobs created sometimes mean jobs lost also, but the gross economic impacts and how it affects the corporate the supply chain and jobs, earnings, and manufacturing. And then we'll move to workforce assessments to identify if those jobs are there or if they need to be created. And that's kind of another part of this task. And you can see from the figure, this is kind of a model of how we do it. The inner circle represents the direct jobs that are created by the construction and operation of the plants. The second circle represents the supply chain jobs, and then the outer circle is all the induced jobs that are as a result of workers going to restaurants and eating there and things like that. Next slide, please. So this is my final slide, and we'll just, it's an expansion of what I just said. It's really an investigation. What are the opportunities for New York, and how is this? What's in it for New York in terms of port development, economic development, and jobs. And we're working on this. We're very excited to present this maybe in the next time, and yeah, and going forward, it's a great opportunity. So thank you.
Thank you very much, Walt. Next slide, please. Some contact information from NREL for folks. Great, thank you. So now I'd like to introduce Katie White with Advizian team to discuss their aspects of the study. Go ahead, Katie.
Thank you, Cheryl. Here are the leads of the Advizian team for this portion of the feasibility study. Next slide, please. The purpose of the permitting roadmap and study is to understand how a Great Lakes wind project could get permitted. This is an important exercise because a New York Great Lakes wind project is novel. It has never been fully permitted before, so we are investigating hypothetical scenarios. This study will demonstrate the major federal and New York State permitting authorities, map permitting requirements from a process perspective, identify the required submission materials and studies, the opportunities for streamlining and efficiencies, and the challenges and roadblocks experienced by similar wind projects. We are looking to understand the big picture process, sequencing, and triggers. Next slide, please. The methodology for the permitting roadmap and study will be to develop a desktop study and literature synthesis. There are key reports and sources available to inform this process. We are now validating our findings with phone interviews with the regulators. These interviews are very important and help us understand the full context of this novel process. We have conducted agency interviews with the New York State Department of State, the New York State Department of Environmental Conservation, the New York State Office of General Services, the U.S. Army Corps of Engineers, and the U.S. Fish and Wildlife Service. Next slide, please. There are two key outputs for this portion, a written report and a graphic that shows all the multiple permitting processes together and how they interrelate as a roadmap. For the roadmap, we are developing a process flowchart demonstrating permit processes, key players, materials and studies needed, and opportunities for public involvement. To the right is an example of an application process flowchart from the U.S. Fish and Wildlife Service. Next slide, please. The relative risks, mitigations, and benefits study will identify the distribution and habitat use of the study area. It will identify potential environmental and health benefits to the region from Great Lakes wind, potential stressors, impacts, and mitigations, and develop a sensitivity map overlaying data sets to show relative risk areas. Next slide, please. The methodology for the distribution and habitat area use, environmental and health benefits, and the stressors, impacts, and mitigations will be a desktop study using available data, scientific literature, agency reports, and publicly available relevant projects. The methodology of the sensitivity study will be to identify risk receptor groups, such as fisheries, vulnerable species, sensitive habitats, cultural areas, and any other potential Great Lakes wind interaction groups. We will weight data layers for each group based on vulnerability and the likelihood of impact from Great Lakes wind. To the left is an example of a weighting matrix showing the low, medium, and high risk values of a receptor group based on their vulnerability to a stressor and the likelihood of impact. This allows for seasonality. One receptor group could have a high risk in the spring and a low risk in the fall for a stressor. Some receptor groups will have a higher weighting than other groups. An example of this is an endangered species critical habitat area will be weighted higher than the habitat of a non-endangered species. We will then perform an analysis in GIS using weighted receptor data to give combined outputs showing relative risk. Next slide, please. Here's an example from the NYSERDA Offshore Wind Environmental Sensitivity Study. This characterized a location to identify potentially suitable areas to consider for wind energy development. This was based on biological sensitivity and produced maps of relative sensitivity in the area, which accounted for seasonality. The 4 maps show potentially suitable areas as they transition from spring to summer to fall and to winter. Next slide, please. And now we'll pass it over to John Brand, our geosciences lead.
Thank you, Katie. So part of Advision's scope is to look at the geohazards and site characterization, and that is in collaboration with NREL, as Walt had noted earlier. And so what we'll be doing is we'll be looking at the notional lake bed and subsurface soil and geologic conditions, and then assessing constraints relevant to siting of offshore wind development. And that could include, the very shallow soils and the superficial soils, and that's relevant to infield and export cable systems. And just as an adjacent topic, that's also the primary location where you will be likely to find anthropogenic pollution, contaminants, and things like that. And so not only will we be looking at the soils, but we will also be looking at the contaminant distribution, key contaminant distribution across the area of interest between the 2 lakes, and putting that into our evaluation for relative feasibility. Then as we get into the deeper subsurface, we will look at the soils and the stratigraphy and the depth of bedrock, and relevant to how we would go ahead and looking at the siting and the foundation type capacity and installability for the wind turbine foundations and substation foundations or other type of deeper foundations. So, we look at the surface for the surface founded or near surface founded infrastructure, and then we start to look deeper into the stratigraphy and the geology and the inferred soils. And of particular interest is the depth of bedrock in terms of what foundation types would work and what water depths for what type of systems, be they a fixed turbine system or a floating system. Next slide, please. And so the methodology that we're going to do is we're essentially going to mine all the available data sets for relevant information. And so that can be superficial information in terms of soil sampling, or that can be subsurface information in terms of depth of bedrock, and also subsurface stratigraphy. So the upper right image that you see is actually geophysical survey data from the lakes. And so we can see where the Paleozoic bedrock is, and we can see a number of different stratigraphic units that are identified, and then the type of stratigraphic unit that it is, the type of geology, and then the type of sediment will help us to understand the distribution of that layer across the lakes, and then also what that means in terms of the foundation and siting feasibility. So what we'll do is we'll look at all of this data, we'll aggregate the superficial soils data and align on the final mapping, because there's a couple of different sources of the superficial soils. So we want to make sure we consider everything to come up with our final kind of superficial soils map. And then we'll look at the mapping of the bedrock and of the subsurface stratigraphy and the distribution from the lakes. And we will geoposition all the relevant data in a geographic information system. And a lot of this is actually published data in public domain articles. So we have to georeference the mapping into GIS so we can aggregate it all together. And then what we'll do is we'll assess all the conditions for the known hazards and constraints to fixed or floating foundation concepts, as well as cable routing and burial. And so various different foundations have various different types of considerations for both fixed and floating systems. And then there's also geologic structure, faulting, and things like that that are pose potential constraints or hazards to offshore infrastructure development, such as offshore wind. And so we'll infer soil conditions from the map geophysical data and the interpretations, and then we'll aggregate and put all of this together, and then develop a relative feasibility ranking criteria to provide into the overall site characterization assessment performed by NREL. And so the image on the bottom right is actually a result of one of those foundation zone siting feasibility assessments, where we took superficial conditions, we took subsurface conditions, we took the consideration for different types of anchors. In this case, this was a floating system, And they went ahead and we aggregated all that together in a weighted criteria, and we developed the overall feasibility map that you see on the right. And in this case, there were some very challenging site conditions for the type of foundations that were being considered over most of the area. Next slide, please. And so we'll also be doing a visual impact study, and there's really three main stages of the study. There's the viewshed analysis, and then there's the cumulative visibility assessment, and then there's the overall visual sensitivity. So if we were to look at traditional viewshed analysis, we would consider the following inputs: elevation of land and marine data, turbine dimensions and the standard observer heights, which are to be determined for this study, curvature of the Earth, and standard atmospheric conditions. And so if we look at the variables, one of the key variables is the radius of the viewshed analysis based on the turbine dimensions. And so as Walt had mentioned, NREL will be coming up with nominal kind of turbine sizes based on their analysis. And then we'll be considering that as the turbine dimensions for the visual impacts. And then the height scenarios that we may run to estimate full or partial views of the turbines, and then the land cover data we'll probably be using instead of the bare earth model, because it typically is a worst case scenario for bare earth, whereas we use land cover data, we can get an improved viewshed screening. And then over on the right side, these are pictures of past projects. There's Block Island, there's Icebreaker, and then there's Cape Wind. And what I would like for folks to note is that these all have set locations for where they want to develop the intended wind farm for these different projects. So if we go to the next slide. So for this study, we don't have any selected sites or any sites of interest. So we're kind of doing something a little bit different here in that we don't have any pre-selected sites or layouts. So we need to go ahead and think about how we might do viewshed analysis a little bit differently on a more holistic kind of screening level. And so what we plan to do is we'll take shoreline locations at a spaced interval and look at the elevation data that we have, which is extremely high resolution elevation data, and also consider land use for the observer perspectives. And so we'll run the analysis basically from a land observer location along the coastlines. We'll also then go ahead and develop an offshore grid pattern of test points starting furthest from shore and working the analysis in and looking at how those results start to show us where the potential visual impacts with shoreline and other considerations are. And then what we'll do is we'll aggregate all of that information together and develop a composite assessment of potential impacts. And then we'll translate those results into relative feasibility criteria to feed up into the overall feasibility screening. And so this is kind of unique that we don't have a site that we actually want to pre-screen the broader area in terms of this as a very early consideration for feasibility. And then the visual sensitivity, what will come out of this is it will establish the initial visible sensitivity for siting turbines within the lakes related to land-based observations. And then it should also identify the additional parameters or considerations or information that we would want to include in more detailed future studies. Next slide, please. And so I'd like to thank everybody for their attendance today. Thank you, Katie and the Avizient team, and I will pass it over to Cheryl.
Thanks very much, John. And thank you to the Avizient team for that information. Next slide, please. Now I'd like to introduce Rick Austria of P-Terra Consulting, who will discuss the interconnection feasibility part of this study. Thank you, Rick.
Thank you, Cheryl. I'm Rick Austria with P-Terra, and together with the Brattle Group, we are consultants to conduct interconnection feasibility, which is the connection of Great Lakes wind power to the electric grid of New York in order to deliver that power to the customers in New York. Next slide, please. So our objectives in conducting this feasibility study are to develop an understanding of the interconnection options, how to deliver that power from Great Lakes wind generation to the electric grid, which we refer to here as the bulk power system. Along the way, we want to identify critical information that may impact the feasibility of interconnecting Great Lakes wind energy. That information that may impact the development of these projects and may limit their capability or enhance their capability to deliver their power. And as well, we are to provide guidance to NREL on determining the points of interconnection or POIs on the grid that are ideal for interconnecting Great Lakes Wind, also identifying any upgrades on the grid itself that may be needed to interconnect Great Lakes Wind. Next slide, please. So the approach we are using here is a standard approach for electric grids, which is to use models known as power flow models. These models represent the future electric system. In this case, we're looking at 2025 and 2030 during summer, winter, and light load conditions. These are the states when the grid is either in an extreme loading situation or is lightly loaded. So we can get the range of capacities available on the grid to interconnect Great Lakes Wind. With these models, we can simulate the capacity for each POI or point of interconnection from a Great Lakes Wind generator to a location on the grid close to the shoreline, primarily along Lake Erie and Lake Ontario, and accounting for factors that compete with the use of the grid, such as other land-based renewable generation that may seek to utilize the capacity on the grid, any potential transmission grid upgrades that may or may not be related to the interconnection of Great Lakes Wind, and the potential retirement of non-renewable power plants, which will increase the capacity for new interconnections, especially from Great Lakes Wind to the grid. And we will coordinate these results with other study teams to determine the location and timing of Great Lakes Wind development and identify the water and land routes for the electrical connections. Next slide, please. So this is a view of the potential points of interconnection along the Lake Ontario shoreline. We've selected substations, electrical substations, which are within 10 to 15 miles of the shoreline as our initial set of locations to consider. So the pinpoints shown here on the figure represent the substations and their substation name. The red lines are the electrical transmission lines. Their ratings may be from 115 to 345 kilovolts. The lower voltage lines will have a lower capacity and therefore can carry a smaller amount of power injected by Great Lakes Wind, and the higher voltage lines will have higher capacity. And the capacities will vary also depending on the conditions on the transmission itself, where other renewable generation on land and other sources of generation that are based thermally may utilize the same capacity. And so the remaining capacity is what we will determine in the analysis. The process is sometimes known as an N-1 analysis, or a condition where the network can lose any single transmission line or element and still be able to deliver its power to the customers. Next slide, please. So here are the potential interconnection points along Lake Erie. There's fewer interconnection points here, closer to the shoreline. The transmission grid is also a smaller, lower capacity grid at 115 kV, except in the region close to Niagara, where we will have 345 kV and 230 kV lines. So in the analysis, we will evaluate each POI and characterize it based on the size of Great Lakes wind power it can support and the sensitivity of each POI to potential use of the grid by other land-based generation resources, other potential transmission upgrades, and retirement of existing power plants. So if you imagine this as a dynamic utilization of the grid, our objective is to identify within that dynamic how to interconnect Great Lakes wind so we can maximize its use of the energy. Once we determine these potential capacities for each of the POIs, then we will look at potential land and water routes that was in coordination with the other teams on this study to determine the ideal selection locations for interconnecting to the grid and studying the grid when the offshore wind, or when the Great Lakes wind is in service. Next slide, please. Thank you for the opportunity to present our feasibility scope. And I turn this over to Cheryl. Next slide, please.
Thank you very much, Rick. And thank you to all of our presenters and for preparing this information and spending the time to discuss these more technical aspects of the study. So now that you have heard from us over the course of the past two webinars, March and then today's, we want to hear from you. Back in March, participants in the webinar communicated that they wanted to see a dedicated public feedback session. And this has been scheduled for 3 weeks from today, Wednesday, June 9th. And it's going to be an evening session from 6 to 8 p.m. Eastern Time. There will be more details on how to participate and register for this public feedback session in the coming days, and it will be posted on the NYSERDA Great Lakes Wind website and sent via email. Please be sure to engage with our website often and that you're signed up for our email list. There is a form on the website itself that you can add your email list and be sure that you are getting these important updates on opportunities to participate. As mentioned earlier in the presentation today, there will be those other subsequent webinars in August and October as the study takes shape and nears completion. And that is all that information is outlined here in this slide. Of course, we are always accepting questions and comments and want to hear from you at our email address, which is greatlakeswind@nyserda.ny.gov. Next slide, please. And with that, we have reached the conclusion of today's presentations. We'll take the remaining time to answer your questions that have come in. So I will be facilitating that. Just bear with me one moment, please. Okay, there is a question/comment here. Thanks for the presentation. Only desktop or any field studies anticipated. It also wasn't clear about what physical biological stressors would encompass. So I can start off the answer to this question by saying that the feasibility study is a desktop study and no new field data will be collected, but existing data will be analyzed in new ways. And I might go to John or Katie or Walt or Rick for that matter to add anything else to that question.
Yes, Cheryl.
Thanks.
Can you just repeat the second part of that?
Sure. Yep.
Thank you.
Yep. What are the physical biological stressors would encompass? Sorry, it wasn't clear about what physical biological stressors would encompass.
Yes, well, of course, we're still in the planning stage, so we don't have any preliminary results for you at this time when it comes to stressors, but an example could be permanent permanent alteration or displacement, and looking at how that could affect biological species and the environment.
Thank you. I'll move on to the next question. How many members of the public are listening to this presentation? So I can say that there are 89 people attended today's attended today's webinar at its peak. And we had about 130 people registered. We understand that it's difficult to schedule the right time to get everybody participating at once. And that is why we record our webinars. So folks who are interested have access to them at their own convenience, and that any questions that come up aren't just limited to being asked live via this webinar. They can be sent in via the website and email address as described earlier. There will also be an opportunity for folks to catch up maybe on what information was covered in these last two webinars, and they are very welcome and invited to attend the public feedback session on June 9th. And I will say that that is going to be a virtual session. We have heard from the public that they would some people would prefer an in-person session, but COVID restrictions are such that we weren't able to plan something like that in the amount of time that we had. And so it will be a virtual session, and we definitely look forward to you participating in that forum. The next question.
Hey, Cheryl.
Yeah.
Hey, Cheryl, can I just interrupt real quick? This is Sarah. I just wanted to maybe be a little clearer on the response to the question about the biological and physical stressors. A lot of the biological and physical stressors that we would experience in a Great Lakes wind project would be somewhat similar to what we look at in offshore wind. So we're thinking about things like noise, like the potential for collision or displacement for birds and bats, considering benthic disturbance and cable laying and things like that. So a lot of that's going to be somewhat similar, but we're also looking at what is specific to Great Lakes and some of the particular habitats and species that are there.
Thank you, Sarah. If for the person who asked that question, if that was clarified, please let us know. And if you have additional questions related to those answers, please go ahead and email us, and we'll be sure that we get you the right information. Thank you. Okay, so next question. Are you studying the impact of interference from the wind turbines on the Department of Homeland Security's radar array that is key to protecting our border security? I will say that radar interference is not a part of this feasibility study. It is, I imagine, would be a site-specific analysis, and consultations with Department of Defense would be identified as a key engagement for that regulatory process. There are working groups that work on this kind of thing. I can send out some more information on the Wind Turbine Radar Interference Mitigation Working Group. And then that I believe Department of Energy conducts. And then I will also say that there is consultation with DoD on terrestrial wind, and that there are operating wind projects near Fort Drum and other places where national security are important, and radar, strong radar signals are also key to being sure that there's no interference by the turbines. If at any point anybody wants to, any of the presenters have something to add, please feel free to chime in, as Sarah did. Thank you. Okay, next question. Where else in the world is there a major industrial wind turbine project operating in a freshwater lake that is also a major source of drinking water? This I'm going to direct to Walt from NREL. Walt, do you mind taking this question?
Yeah, I'll take that. I'm not sure if it has drinking water, but there's a freshwater project in Sweden, Vänern, it's called Windpark Van Ern. I'm not sure the specifications, but we can investigate that a little further for the person who asked the question. But there is plans to develop more freshwater in Sweden. In particular, I think there might be some Finnish project as well.
Thank you so much. While I have you, if you don't mind, I'm going to ask another question of you that I think you're best poised to answer. Is there a general number of megawatts that is anticipated for Lake Ontario, understanding that this is a feasibility study and not a planning or siting study for the lakes?
I know the answer. I don't know the answer to that question. It's I think we can if someone wanted to do a back of the envelope type analysis though on their own, we generally look at the area that's available as a potential, and the metric that we use is 3 megawatts per square kilometer, and that kind of gives you an idea of so about maybe look a little larger number, 120 square miles would create would be enough for about a gigawatt of capacity, and you can scale that however you want to.
Thank you. Sorry to put you on the spot there. Appreciate the answer.
Worries.
Great. Next question. How about direct contact with lakeshore residents? Have you considered this idea as part of your study? I would say that we welcome any members of the public, particularly lakeshore residents who have concerns, I'm assuming about visibility and other impacts, that they participate in the public forum on June 9th and continue to submit questions and comments to NYSERDA, so these can be considered for input into the feasibility study. I will say that if and I don't know, I'm just assuming if this part of this question is a viewshed or a visibility issue, we have seen here and can confirm that a visual impact study is part of the feasibility study, and there'll be more information as that develops. Okay, let's see. I'm just taking a look here. You seem to be approaching this study as a how we do it rather than should we do it proposition. Is this true? I will say again that this is a feasibility study that is going to identify risks as well as opportunities. And I think the should we comes after the feasibility study is written and produced, and we see what the results of that are. Will the study contact tribal nations with ancestral connections to Lake Ontario and Lake Erie related cultural resources in order to understand their impact on this feasibility study? Yes, an assessment of cultural resources is going to be included in the feasibility study, and New York State is currently working on those dialogues with tribal nations to understand areas of importance and sensitivity of submerged lands. This is something that will be addressed in a few of the study aspects that were described when considering the lake bed and sediments. And additionally, NYSERDA is targeting those dialogues with tribal nations in order to understand that as part of more of like what we were considering the regulatory processes and considerations for that would go into permitting.
Yeah, and Cheryl, I would just add to that too. This is Sarah again. If you have a particular comment or information that you want to provide, please connect with the state, with Cheryl, with the folks associated with the project, and we're very interested in getting all the input that we can in that aspect of the study. So we're obviously trying to reach out ourselves, but it's always helpful if folks have something they want to share, if they also reach out to us.
Thank you for elaborating on that. Appreciate it very much. Will the public forum on June 9th allow the public to speak or only to type questions? This is going to be a verbal feedback from the public. I didn't go into much more detail on that because we are setting it up right now, but this is going to be, you will have access to the microphone and a certain amount of time to make your comments that will be recorded and summarized by the facilitators that we've hired to run the session. It will then be either appended to the report or certainly read by the contractors and taken into consideration to be sure that the subject matters are actually being addressed within the study. Taking another look at questions here. Do you have vessels to build the turbines? Well, I can say that as part of NREL's work, the supply chain and port assessment study will likely look at this question. Again, not trying to put anybody on the spot, but Walt, do you have any insights into this as of yet? And it's okay if the answer is no. Or anybody from NREL.
That is part of the study. So, and we haven't, we don't have a conclusion on that yet. The vessels that are necessary to install projects out in the Atlantic are very large. They won't fit through the locks. So we know that there will be a limitation on the type of vessel that will be needed. And we haven't established whether that vessel exists in the lakes or if it needs to be built. Or alternatively, there could be technologies that don't need vessels. So we're also looking at those options. So there's a wide spectrum of possibilities. For floating technologies, the types of vessels are much different than they are for fixed bottom technologies that have to be installed on site. So we will be discussing that and including that in the study.
That's great. I have another question related to port development that I'm going to try to answer, but Walt, if you have anything to add to this next answer, I'd appreciate that too. How can counties and other local governments participate with respect to port development and other economic development opportunities? I'll start by saying I think it's probably too early in the process for that, but the supply chain assessment that Walt described will be able to identify potential ports, and that I know that NREL is working with specific stakeholders in the lakes and at the port sites to gather more data and more information. Walt, is there anything you want to add to that?
No, I mean, just to reiterate, the ports will have to be on the lakes, and we're identifying which ports might be suitable. I think that it should be recognized that probably any port that gets used is going to need to be upgraded, and there'll need to be some investment in that port, which will generate economic activity in that area. And part of the assessment is also the assessment of the qualifications of the workforce in that region and whether or not there'll need to be training and additional jobs brought in for specific to those upgrades that are necessary. So with those upgrades will be opportunity for supply chain development. Ports tend to be magnets for economic development. So we'll be assessing in some of the jobs and impact studies that we're doing some of those relationships.
Thank you. We have a few minutes remaining. I'm going to take one more question here. I'm going to ping the Advisian group for this one. John, I know that you had talked about sediments and some contamination, potential contamination. So I have a question here. With over 100 years of heavy metals on the bottom of Lake Ontario, one would think real field study would be required to determine how the impact of putting heavy metals back into the water columns can impact the food web from plankton to top line fish like trout and salmon. And I think that that's sort of a comment, but there's also maybe an opportunity here to elaborate a little bit on that. And I know, Katie, you talked a bit more about biological and trophic interactions as well, and your environmental sensitivity. So in our remaining few moments, if there's anything you'd like to add to answer that question, I appreciate it. Thanks.
Yeah, I'll take the heavy metals question. So valid question, and I think that's probably part of the next steps after this feasibility study. Right now, we're looking at available data, and there have been a number of different sampling programs across the Great Lakes to characterize the contaminant distribution. So we're using that as a guide now, and there's also been some advanced modeling done in terms of how the sediments may move around and the chemical constituents may be transported by currents and redistributed. So we're using that available data now to form the basis for the assessment of the initial feasibility and also to make recommendations on what may be done in the future.
Thank you so much. I didn't know if Sarah or Katie wanted to add anything about the biological aspect of that.
Yeah, I think John kind of hit that on the head. Part of the effort is to identify where more studies are needed and what studies are appropriate for permitting and mitigation, monitoring, things that are going to happen moving forward. If, in fact, a decision were to be made that this was feasible and that New York wanted to pursue it, which is not necessarily the case, but were it to happen, there will be outputs from this study that will identify things like that as needing additional research or monitoring. So we again encourage people to continue to contact us with ideas and thoughts on this, and really contact New York, obviously. And we are following the comments and questions and considering all of these things as inputs into the feasibility study. So we really appreciate these questions.
Terrific. Thanks so much. With that, we're going to conclude today's webinar. If you asked a question and it wasn't answered, be sure that it was recorded, and in due course, it will be answered. So thank you very much for attending today's webinar, and have a wonderful evening, everyone.